Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over the steps on how to draw Lewis dot structures, and I'm going to go over a few practice problems. Now, it is important to follow these steps. I guarantee that if you follow these steps in order every single time, you will never get the wrong Lewis dot structure. But you have to follow the steps. You can't shortcut, you can't just try to wing it. You can't skip a step unless, of course, that step doesn't apply, but you got to follow the steps in order. So let me go over the steps and then I'll go over some practice problems. Okay, so step number one is add up the valence electrons for all the atoms in your compound. So you're going to be given a formula, and the formula has the type of atom and the number of each of those atoms. Using your periodic table, you can figure out the number of valence electrons that each of those atoms have. Go ahead and add them up. The other thing that I want to mention is, and I didn't write it down, so I'll write it down right now, is you're going to want to also take in consideration the charge. So if you're given like a polyatomic ion or something along those lines, if you're given an ion with charge, you got to take that in consideration. So if you have a negative charge on your ion, that means you have more electrons. So you have to add those electrons to your total. So if you have a -1 charge, then that means you have an extra electron that you have to add to your total. If you have a -2 charge, then you've got to add 2 more electrons to your total. -3 would be adding 3. If you have a positive charge, then it's going to be the opposite. That means you don't have enough electrons, or electrons are missing. So you're going to have to subtract those electrons from your total. So let me add this. So add electrons for negative charge and subtract for positive charge. And again, I'll go over examples of that in a moment. Okay, so what's the second? The second step is, once you've got your total number of valence electrons for your molecule or your polyatomic ion, you got to draw the skeletal structure. And for every bond you draw, you're going to subtract 2 electrons from the total that you have. So when you draw your skeletal structure, all you're going to do is bond everything to the central atom, and then only use single bonds. Only use single bonds to start with. We'll get to double and triple bonds in a moment. But you're going to connect everything with single bonds to the central atom. If you've got more than one central atom, then you're going to have to bond them to those 2 or 3 or whatever number of central atoms you have. So a couple of things. The central atom is the least electronegative atom. That's the one that's going to be the central. So you have to figure out which one is the least electronegative. It's usually the first one written in the formula, but not always, right? So that usually is the case, but not always. So double check with the electronegativity. Okay. If you have hydrogen, hydrogen is never going to be the central atom, even if it's written first. So in things like acids, usually you're going to write the H first in the formula. That is not the central atom. It'll never be the central atom because hydrogen will only bond once. You need a central atom. It's going to be something that's going to bond multiple times. So sorry about that. So hydrogen is not going to be the central atom. Halogens, the group 7 elements, are only going to bond once if they are an outer atom. So if you've got a halogen that's bonded to your central atom, only one bond. They're not going to have multiple bonds, only one bond for those. Unless, of course, they are the central atom. If you have a halogen and this halogen is the central atom, then that will bond multiple times unless you've got fluorine. Fluorine will only ever bond once, so fluorine will never be a central atom. It's kind of like hydrogen, right? So hydrogen and fluorine will only bond once. Okay, so now you've got your skeletal structure. You figured out what your central atom is. You bonded everything to the central atom. Now what? Third step. Oh, and by the way, just to remind you, after you've constructed your your skeletal structure, make sure that you subtract 2 electrons for each bond that you put together, right? So every bond has 2 electrons. So if you use the bond to stick your atoms on the central atom, then you're going to have to subtract that from your total. So with whatever's left over, your electrons, whatever electrons you have left over, you're going to give the outer atoms, not your central atom, you're going to give the outer atoms lone pairs, 2 dots, to give them an octet. So you're going to give an octet to your outer atoms by giving them enough lone pairs to get that 8 electrons. So they're already bonded once, at least, right? So they're already bonded once, so you're going to have to add lone pairs to them to create an octet. If it's hydrogen, hydrogen's fine with 1 bond. You don't need to add any lone pairs to hydrogen. But other atoms, you'll add lone pairs to them to get that octet. So once you gave them their octet, you're going to subtract the electrons that of the lone pairs that you put on your outer atoms. You're going to subtract those electrons from the total that you started with in step 1. So subtract those. Now what do? If you have electrons left over, then you're going to put those electrons on the central atom as lone pairs. So once you have used up all of your valence electrons, right? Okay, sorry. If you have any electrons left over, step number 3, you're going to put them on the central atom as lone pairs. So any electrons you have left over goes on the central atom. If you don't have any electrons left over, then you're done. So, but after I misnumbered here. So this is step 4, and this is step 5, and this is step 6. Okay, so after step 3, if you don't have any electrons left over, you're done. And at this point, you want to check your structure to see if everyone is happy. And I'll talk about that in a moment. But if you've got electrons left over, then at step 4, you're going to give those electrons, any electrons you have left over, you're going to put them on the central atom or central atoms if you got more than one, as lone pairs to give them an octet. If you've got more than enough for an octet, then just keep putting them on the central atom. So if you've got, enough electrons left over to give your central atom 10 electrons, 12 electrons, go ahead and put them on the central atom as lone pairs. Number 5, at this point, your electrons should be used up. You should have no electrons left over. So once you have used up all of your valence electrons, you're going to check to make sure all of the atoms in your structure have a complete octet. So double check, make sure everyone's happy with an octet, but not everyone's going to need an octet. So for example, there are some exceptions. Hydrogen, as I said, is okay with bonding once. So if it's bond once with 2 electrons, it's going to be fine. That'll be fine for hydrogen. For beryllium is okay with 4 electrons, so 2 bonds. So if beryllium has 2 bonds, that's fine for beryllium. And for boron's going to be happy with only 6 electrons, and that means 3 bonds. So that's okay for boron. So these are exceptions to the octet rule. Other exceptions are elements in the 3rd period or higher. They can have what is called an expanded octet. That means they can have more than 8 electrons or more than 4 bonds, right? So they can have, they could have 4 bonds and 1 lone pair. So that would be 10 electrons. So they could have 10 electrons, 12 electrons. So, so that's okay if you have your central atom is an element that's in the 3rd period or lower. So for example, phosphorus and sulfur are often central atoms that can have an expanded octet with 10 electrons or 12 electrons around them. Okay, and finally for organic molecules, the honk 1, 2, 3, 4 rule is really nice to keep in mind. That's referring to the bonding patterns of certain elements or certain atoms that are in your organic molecules. Organic molecules are molecules that have carbon, hydrogen, oxygen, sulfur, and so on. So they tend to have those elements. So especially carbon, hydrogen, and oxygen, those are going to be organic molecules. And the honk 1, 2, 3, 4 basically says that it goes in order of these 4. So hydrogen will bond once. Hydrogen loves to have 1 bond. So if you got an organic molecule, hydrogen's going to bond once. Oxygen loves to have 2 bonds. So whenever you're putting your organic molecule together, you want to make sure that oxygen has 2 bonds. Nitrogen loves to have 3 bonds, so you would expect nitrogen in your organic molecule to have 3 bonds in it. If it doesn't have 3 bonds, then something might be wrong. And carbon loves to have 4 bonds. So hydrogen 1, oxygen 2, nitrogen 3, and carbon 4 bonds. So that's referring to the bonding pattern of these elements. These are typical of those elements in your molecule. So just pay attention to that. That might be helpful as well. Now these don't work all the time. There are exceptions, but generally speaking, this is a safe rule of thumb to follow. Finally, if if you check if all of your atoms are okay, once you've checked, then you're done. You've got the correct Lewis dot structure. If you find that if you check and you find that your 1 or more of your central atoms do not have an octet, then you need to make sure that they have an octet. And since you don't have any electrons to give anymore because you used them up already, what you're going to have to do is move lone pairs and create double or triple bonds. So basically, you're going to take a lone pair from one of the outer atoms and you're going to move it and make a bond out of it. And so that way, that lone pair can now be shared between the 2 atoms so that the 1 central atom or whatever central atom that you had that was not happy with an octet will now be happy with an octet. Okay, so these are the steps. Now I'm going to go ahead and show you a few examples. But first, you're going to want to pause the video, write this down, so that way you can follow the steps along with me as I'm going over the problems. So pause the video, write this down, and then I'm going to go over some examples. I'll be right back. Actually, I just forgot. I should step out of the way. There you go. Pause the video. Okay. Okay, welcome back. So here are a few examples. So let's start with number 1. So what am I going to do? So I have hydrogen here, H2. Step 1, write out the total number of valence electrons. So since hydrogen is in group 1, that means each hydrogen atom has 1 valence electron. So since I have 2 hydrogens here, that means I have 2 valence electrons. So I have 2 valence electrons total. So now I'm going to build my skeletal structure. Well, since I only have 2 atoms, they're going to have to be bonded together. So I have hydrogen here, hydrogen there, and then I draw a line to bond them. Now you can use 2 dots. A lot of times you'll see dots there. I like to draw lines to bond my atoms together. So here I have 1 bond. And so my skeletal structure is this right here. Now, I don't have a 1 central atom here since I only have 2 atoms. They're bonded to each other. So this is my skeletal structure. And so now, since I used one, so I'm step 2. So step 1, sum up your electrons. Step 2, skeletal structure. And now I'm going to subtract out the electrons from the bond that I used to create the bond. So since there's 2 electrons in every bond, so I'm going to subtract out the 2 electrons, and I have no more electrons. So since I have no more electrons, I can skip step 3, step 4, step 5, and then, or step 5 would be check this to make sure everyone's happy. So since hydrogen is happy with only 2 electrons or 1 bond, so both of these are happy. So this would be my Lewis dot structure for H2. So it's that simple. Let's go ahead and do water. So for number 2, water, now I have to sum up or add up all of the valence electrons of the atoms in water. So since I have 2 hydrogens, that means there's 1 valence electron for each hydrogen because hydrogen is in group 1. So I have 2 electrons from my 2 hydrogens, so 1 from each hydrogen, and I have oxygen. So oxygen is in group 6, so it has 6 valence electrons. So I have 6 valence electrons from oxygen. So I add these together, and I have a total of 8 valence electrons. So I'm going to use those to build my Lewis dot structure. So step 2, draw my skeletal structure. Now, I said that hydrogen is never going to be the central atom because it only bonds once. So I also said that the lesser electronegative atom would be the central atom. Well, since hydrogen is the lesser electronegative atom, you would say, okay, well that would be the central atom. But since hydrogen can only bond once, it can't be the central atom. So oxygen has to be the central atom. So I'm going to draw oxygen as the central atom, and the 2 hydrogens are going to be bonded directly to the oxygen. Okay, so there's my skeletal structure right there. All the atoms are bonded together. My hydrogens are bonded to the central atom. And so now I have to subtract out the electrons I used in the bond. So 2 for each bond. So that's 4. So I'm going to subtract out 4 electrons. And I have 4 electrons left over. So I finished step 2. Now it's off to step 3. Step 3 says that if you have electrons left over, you're going to put them on the outer atoms, right? Outer atoms to give them a full octet. Well, in this case, hydrogen is the outer atom. So each of these are happy. Each of these atoms is happy with just 1 bond, 2 electrons. So I don't need to give the hydrogen an octet. And they don't want an octet. They're happy with just 2. So step 3 does not apply here, so we can skip that. Step 4 says if you have electrons left over after that, then you put the electrons that are left over on the central atom as lone pairs. Since I have 4 electrons left over, I'm going to put those on the oxygen. So 1 lone pair, that's 4. So I've used up my 4 electrons, so I have 0 valence electrons left. So now I go to step 5. Step 5 is if you have, the next step would be to double check to make sure once that everyone is happy in your skeletal structure. So since I have no electrons left over, I double check. So hydrogen is bonded once. That's great. Hydrogen loves to bond once, so hydrogen is happy. And then I double check the oxygen. Oxygen has 2 bonds, so that's 4, right? 4 electrons there. It has 2 lone pairs, that's 4, so that's a total of 8. So oxygen is happy with an octet. So everyone is happy with an octet. Also, if you remember the honk 1, 2, 3, 4 rule, you'll notice that hydrogen is bonded once, and oxygen has 2 bonds and 2 lone pairs. So oxygen loves to have those 2 bonds. So again, we're happy with this Lewis dot structure. So this is the Lewis dot structure for water. We're done. Okay. What about number 3? We got carbon tetrafluoride, so CF4. So once again, we have to add up all our valence electrons for CF4. So let's add those up. Carbon, we only have one carbon. Carbon's in group 4, so that is 4 valence electrons. So that's going to be 4 valence electrons for the carbon, okay? And we have 4 fluorines. Fluorine is in group 7, so it has 7 valence electrons, and we have 4 of them. So 4 times 7 is 28. So we have 28 electrons from our fluorine, so carbon, fluorine. So we add these together, and we have 32. So we have 32 total valence electrons for our CF4 molecule. So now that's step 1. Step 2, draw the skeletal structure. So looking here, carbon is written first. We look at carbon and fluorine. Fluorine is the more electronegative atom, so it's not going to be the central atom. Plus, we only have one carbon. So carbon is less electronegative, so that's going to be the central atom. It's written first, which is normally the case, not always. And also, we have more fluorines, so it makes sense that the fluorines would be bonded to the carbon. So carbon is going to be our central atom. So we draw our carbon in the middle, and we're going to bond the 4 fluorines to the carbon. And so we're going to put F there, an F there, an F there, and an F there. So that's our skeletal structure. We bonded everything once to the central atom carbon. Now we subtract out the electrons for each bond. So there's 2 electrons per bond. We have 4 bonds, so that's a total of 8. So we're going to subtract out 8, and that gives us 24 left. So we have 24 electrons left. So now we're finished with step 2, now to step 3. Step 3 says put lone pairs on your outer atoms to give them an octet if you've got electrons left over. We have electrons left over, so we're going to give our fluorines lone pairs to give them an octet. So we're going to put a lone pair there, a lone pair there, a lone pair there, a lone pair here. So this one's going to get 3 lone pairs, 1 on each side. This one's going to get 3 lone pairs. And this one's going to get 3 lone pairs. So we've given all our fluorines lone pairs. They all have an octet now. Now we're going to have to subtract the lone pairs that we used from our total. So we have 6 here, and then we use the 6 for each. So 4 times 6 is 24. So we'll subtract out 24, and we have 0 left. So no more valence electrons. So step 4 would be, well, if we had electrons left over, we would add them to the central atom as lone pairs. We don't have any left over, so we can skip that step. So to step 5, double check our Lewis dot structure. Make sure everyone's happy with an octet or duet or whatever the case may be. So here we see that each fluorine has 3 lone pairs, that's 6 electrons, and 1 bond, that's 2 electrons. So 6 and 2 is 8. So each fluorine is happy with 8 electrons. They have an octet. So that's good. And you'll notice that carbon has 1, 2, 3, 4 bonds, which is typical of carbon. And also each bond has 2 electrons. So that's 8 electrons for carbon. Carbon's happy with an octet. Everyone's happy? So we are done. This is our Lewis dot structure for CF4. Okay, let's move on to NH3. So NH3 has a nitrogen and 3 hydrogens. So we got a first step, total up the number of valence electrons for our molecule. So nitrogen Nitrogen is in group 5, so it has 5 valence electrons. And hydrogen, as we said, is in group 1, so each hydrogen has 1 valence electron. So hydrogen has 1 valence electron. We have 3 of them, so that means we have a total of 3. So we add 5 and 3, and we get 8 valence electrons for our NH3 molecule. So now that's step 1. Step 2, put our skeletal structure together. So our skeletal structure is going to be such that nitrogen is written first. Usually the central atom is the first one. Not always, but usually. Also, again, we only have nitrogen and hydrogen, as I said, is never going to be the central atom. So nitrogen has to be the central atom. And so we have these 3 are going to be bonded to the nitrogen. So nitrogen is going to be our central atom, and we're going to bond the 3 hydrogens to the nitrogen. So that's step 2. We're going to now subtract out the bonds, or subtract out the electrons from the bonds. So we have 2, 4, 6, 2 for each bond. So that's 6. So we're going to have to subtract that from our total here, which is 8. So 8 minus 6 is 2. So we have 2 electrons left over. So again, now we're at the step 3. Step 3 says if you have electrons left over, add them to your outer atom to give them, or atoms to give them an octet. But here our outer atom is hydrogen. Hydrogen doesn't want an octet. It's happy with only 2 electrons. It's already got the 2 electrons from the bond. So we're not going to add any lone pairs to our hydrogens. So we can skip step 3, go to step 4. Step 4 says if you've got electrons left over, add lone pairs to your central atom. So we have 2 left over. So we're going to add 2 electrons. We're going to add 1 lone pair to nitrogen. And so we're going to subtract that out. We have no more electrons. So now what do we do? So since we have no more electrons, we have to check to make sure all the atoms are happy in our Lewis dot structure. So if we look at the hydrogen, every hydrogen is bonded once. That's all hydrogen wants. So hydrogen is happy with 1 bond. And if we look at nitrogen, we have 3 bonds, which is 6 electrons, 2 electrons per bond. And it has a lone pair, so that's another 2, so that has 8. So nitrogen has an octet. It's happy. Also, notice that nitrogen has 3 bonds. The honk 1, 2, 3, 4 rule. Nitrogen loves to have 3 bonds. It has 3 bonds. So that's another reason why this is okay. So that is our Lewis dot structure for NH3. So I'm going to continue in my next video. So I'll continue with the rest of these, and I'll show you how to do the Lewis dot structures for these molecules here. So if this is helpful, if you've enjoyed this video, if this was enlightening in any way, please like my video. Hit the like button right there. Also, subscribe to my channel. Hit that notification bell right up there, so that way you can be notified by other videos I put out. And also, put a comment down in the comment section. Let me know what you think. Ask me questions. I love questions. Thanks for joining me, and have a great day.